Hello and welcome back to another 11 plus video. Today we have a sample paper from Alleyn's that we are going through. It's a maths paper, so we're going to go into the paper, work out all the solutions and see the best way to answer all of these questions. Let's get straight into it. Okay, so let's start off with a pretty simple opener. How many minutes are there in 3.5 hours? So here, it's not very tough. The main thing is just not making any silly mistakes. So the first thing we know is how many minutes there are in a single hour. So we know if we have minutes here and we have, let's say, hours here, we know that 60 minutes make up 1 hour. So now we're told to scale this to 3.5 hours or 3.5. So we can use this logic. Just as we're multiplying the hours column, right? This column here, just as we're multiplying the hours column by 3.5, we can work out how many minutes this should be equal to by multiplying the minutes column by 3.5. So how do we do this? 60 times 3.5, well, 60 times 3 is 180, right? Because 6 times 3 is 18, but then it's 60, not 6. So we have 180. And then 0.5 times 60 is 30. It's half of 60, 0.5 times 60. So we have the 180 and then we have the 30. So it should be 210 minutes, which we see is an option right here. So the answer is C. Okay, so now for this next question, which of these fractions is equal to 0.8? So we can work this out. 0.8. The key here is to not get distracted by all of these distractor answers, right? Like these answers that the examiner puts in just to distract you from actually working out the real answer, like 1/8. You see 0.8, you see 1/8, you think, oh, it might be 1/8. No. If we're going to do this, we have to take it step by step and understand what's going on. And really what's going on is we have different columns once we move past the decimal point. So we have the tenths column. And then if we had another number here, this would be the hundredths column. And it goes on like this. This would be the thousandths column. But in this case, we just have 0.8. So because this 8 is over here, we're working in the tenths column. And because we're working in the tenths column, we know this is 8 out of 10. The same way, if the number was 0.08, this 8, this value, would now be in the hundredths column, right? And because it's in the hundredths column, this would be 8 over 100. That's how this works. So the answer is not 1/8. The answer is 8 over 10. But we can see that the answer, or that value, 8 out of 10, is not one of our answer choices. And that's because the examiner is expecting us to simplify this fraction and put it into its simplest form. And we can do this by taking out the common factor of 2. Why? Because 2 goes into 8 and 2 also goes into 10. 2 times 4 is 8. And 2 times 5 is 10. And therefore, we can simplify this fraction 8 over 10 and turn it into 4 over 5 by taking out that common factor of 2. Now, for this next question, we're working out which one of these numbers is the smallest. Now, we're going to use a lot of the same logic and understanding that we just went through in the previous question, because all of these numbers are smaller than 1, right? We have 0 point something. So here, to work this out, we have to have a good understanding of those same columns we were talking about. The tenths column, the hundredths column, thousandths column, so on and so forth. So for example, if we take these first two answer choices, 0.0801 and 0.08, which one is smaller? Well, it's going to be B, 0.08, because 0.08 is the same thing as 0.08000 onto infinity. But A has 0.08, but then it has 0.1. So that 0.1 at the end means it's just a bit bigger than 0.0. So you see, it's all about comparing the columns as we move further right from the decimal point. So now let's compare B and C and go through the rest of these answer choices. We have 0.08 and then 0.081. Well, here in the thousandths column, we have a 1, where here in the thousandths column, we have a 0. So therefore, this has to be bigger. C has to be bigger than B. And then if we move on to D, D is also going to be bigger than B, because although it's quite far along, in the, not the tenths or the hundredths or the thousandths or the tens of thousands, but in the hundreds of thousandths column, we have a 1, where in that same column for B, again, we would have a 0. So D is bigger than B. And same thing for E. E is quite a bit bigger compared to the rest than B, because yes, we have the 0.08, just like we have in B, but then straight away in the thousandths column, we have that 8. We have 8 thousandths, and here we have 0 thousandths. And of course, because 8 is bigger than 0, E is bigger than B. Now for this question, we simply have to try and be realistic, working out the most likely length of a television remote control. So here, it's not going to be 0.17. That's far too tiny. And the same thing with 1.7 centimeters. Very, very small. If you think about a ruler and you think about 10 centimeters or a 30 centimeter ruler, think about how small only 1.7 of those centimeters would be. It can't be B or A. 17 centimeters. Now, this seems a bit more likely. Again, think of an object that you are familiar with, that 15 or that 30 centimeter ruler. Think about how big that is in your head. If we half that into a 15 centimeter ruler, and then we think about the size of a TV remote control, it's around that size, the 15 centimeter mark. And therefore 17 centimeters is reasonable. It's realistic. So C looks like our answer, but we can confirm that because it's definitely not going to be D, 170 centimeters. That's more than a meter. That's 1.7 meters. That's far too long. And of course, E is just going to be a joke. So C is our answer. Think about familiar objects. Now, for this question, we have to understand bid mass. If we don't get bid mass right, then we will not get this question right. So bid mass telling us the order that we tackle these kind of questions in. Because we see we have subtraction, we have multiplication, we have addition. So we could start answering this question from so many different places. As you see for this question, we could start with 12 minus 2. Or we could start with 4 plus 3. Or we could start in the middle with 2 times 4. So how do we know where to start? Especially when starting in different places affects our answer. That's where bid mass comes in. So because we have bid mass and we know that it's brackets, indices, division and the multiplication, addition and subtraction on the same level, we know that multiplication is what we should start with. And therefore we start by doing 2 times 4. And this 2 times 4 gives us 8. And now we have 12 minus 8 plus 3. And now we're on this level here, addition and subtraction. And these are on the same level, so we can take it simply going left to right. So 12 minus 8 gives us 4. 4 plus 3 gives us 7. And therefore our answer is A. Okay, so here for this next question, we have to be very logical. So we know one of the angles in an isosceles triangle is 30 degrees. Which of these is a possible other angle in the triangle? So first things first, we need to understand what we mean when we say isosceles triangle. This is an example of an isosceles triangle. And the whole point with an isosceles triangle is that we have two sides of equal length. And usually we denote those two sides with these dashes that we put through the sides of the triangle that are of equal length. So in this example, the examiner is telling us that this side here and this side here are of equal length, right? So that's an isosceles triangle, two sides of equal length. But the next important thing to understand is that because we have two sides of equal length, that means we have two angles of equal value. So in this case, this angle here, A, would be equal to this angle here, also A. And then this angle here would be a bit different. It would be B. And then to answer this question, we combine that understanding of an isosceles triangle with the understanding that every single angle on a triangle needs to add up to what? 180 degrees, no matter what the triangle is, whether it's equilateral, scalene, isosceles, right angled, every single triangle has to add up, or the angles inside the triangle have to add up to 180 degrees. Make sure you remember that. So now with this understanding, we can answer this question or tackle this question at least, because really we have two scenarios. We're told one of the angles in an isosceles triangle is 30 degrees. So it's either that this 30-degree angle is B and the other two are different and equal, or I'll put it in green now, different scenario. The other scenario is that one of these two equal angles are 30 degrees. And then B is different. We have those two scenarios. So based on those two scenarios, let's work out the possible angles in this triangle, which will help us answer this question. So let's do scenario one in red. Okay, scenario one right here. In this case, we're saying that this angle B is 30 right here. If this was the case, what must these other two angles A and A be? Well, if we know that the whole triangle adds up to 180 and B is 30, that means these two must add up to give us 150, right? It's the 180 of the entire triangle minus this 30 for angle B. 180 minus 30, giving us this 150. And if we know that A plus A is 150, that means 2A is 150. And if we divide both sides by 2, left-hand side and right-hand side of the equation, then A has to equal 75 degrees. So that's one of the options, right? We have 30, 75, 75. And then what about scenario 2? So in scenario 2, we're saying that the 30 is one of our angles A. So this would be 30 and this would be 30. So these two add up to give us 60. And in that case, this angle here would have to be 120, right? Because we have the 180 minus the 30, 30, right? Minus 30, minus 30, giving us 120, telling us that this angle here, the remaining angle, has to be this 120. So from scenario 1, we have 75. From scenario 2, we have 120. So now let's look at our answer choices, and we see that E has to be our correct answer, 75 degrees, based on scenario 1. Okay, so here we have a question that shouldn't be too hard if you understand your fractions. We're told 1/4 of the pupils in a class are girls, the rest are boys. What is the ratio of girls to boys? So, if we know that 1/4 of the pupils are girls, that means 1/4 are girls. That's what a quarter is, 1/4. And therefore, this means that 3/4 are boys. So let's really deconstruct that language. 1/4, 1/4 is fraction, are girls. 3/4, 3/4 are boys. And I'm saying it really slowly and weirdly on purpose, because when you say it like that, you can understand how this ratio must work. Because overall, we have a group of 4 pupils, for example, and in every single group of 4 pupils, 1/4 are girls. Remember what we said over here? 3/4 are boys. What we said over here. And therefore, the ratio must be 1/3. And we can even prove this. Let's say we had a class of 12 pupils, okay? You have a class of 12 pupils. If 1/4 are girls, that's 1/4 of 12, right? Giving us 12/4. Cancel vertically, we have 1 and we have 3, so it's 3/1, right? Or 3. And then for the boys, we have 3/4 of 12. In this case, we have 3 times 12, 36, divided by 4, which is 9, right? So we have 3 girls and 9 boys out of the 12 pupils. And of course, we can cancel this down to 1 and 3. So this is our answer, 1, 2, 3, which is C. Okay, so now for this next question, we have to work out the hours and minutes between 9:34 in the morning and 1:21 in the afternoon. And the way to do this is to take it step by step. You don't want to treat this like normal numbers and try and subtract them in a column. That's not going to work, right? We don't want to do this. Instead, we want to take it very methodically when we're working with clock times and simply go to the hour and then work out the number of hours and then simply go to the minute. So let's break down what I mean there. So if we're starting at 9:34, then let's first get to 10 a.m. And we do this by adding on how many minutes? Well, it's going to be 26 minutes, right? The 6 gets us to 40, and then the 20 gets us to the hour, 60 minutes in an hour. So plus 26 minutes. Then we're going from 10 a.m. and we're going all the way to 1 p.m. or 1300, right? How many hours is this? This is going to be 3 hours. And then we're going from 1300 to 1321. And this is going to be 21 minutes. So you're seeing we're taking it step by step. So now we have 3 hours plus 26 minutes plus 21 minutes. And that should give us 3 hours and 47 minutes. Because 26 plus 21 is 47. So that's our answer, and we can see that's also an option. Option B, 3 hours, 47 minutes. That's how we work out these clock difference questions. Okay, so here we're simply going to draw upon what we were talking about in previous questions about the different columns past the decimal point. Remember, we were talking about the tenths column and the hundredths column, thousandths column, so on and so forth. That's all the knowledge we need to answer this question. What is the value of the digit 9 in the number 32.597? Well, here, this 32, the 3 is a 10, and then the 2 is a unit. Then we have the decimal point. The 5 is in the tenths column. The 9 is in the hundredths column. 7 is in the thousandths column. So we care about the 9. Let's make it red. So this 9 is in the hundredths column. And because it's in the hundredths column, it represents 9 hundredths. So the answer is D. Okay, so here for this next question, to work it out, there are a few steps we have to go through. So let's go through each of those steps one by one. I buy a pen and a pencil for £1.10. The pen costs 50p more than the pencil. How much is the pen? Okay, so here we need to write out some equations. And effectively, we need to turn this question, we need to turn these sentences, these words, into maths. So how can we do this? Well, for the first sentence, I buy a pen and a pencil for £1.10. What does that mean? That means pen plus pencil equals 110p, or just 110. We've converted that £1.10 from pounds to pence. But then we have a second equation. And do we know the second equation? Is there a second equation? Let's try and find it. The pen costs 50p more than the pencil. What's the equation, or what's the maths in that sentence? Well, the pen costs 50p more than the pencil. So whatever the pencil costs, the pen has to cost 50p more. Whatever the pencil costs, the pen has to cost 50p more. So that means the pen equals the pencil, like we just said, plus 50p, or plus 50. This is some more advanced maths, but now we can use substitution. And that simply means understand that we have pen here and we also have pen here. So we can substitute what we know about pen here and chuck it over here. And doing this will help us to understand what the pencil is. So let's do it for real so we can see what's going on here. We know that pen plus pencil is 110. But we also know that pen is pencil plus 50. So if we know these two things, we can substitute pen for pencil plus 50. That's all substitution is. So now we have pencil plus 50 plus the rest of this equation. Pencil equals 110. Now pencil plus pencil is 2 pencil. So we'll bring it up here. 2 pencil plus 50 equals 110. Then we can work out what pencil is. First, we can minus 50 from both sides of the equation. Remember, whatever we do to one side, we do to the other side. So now we have 2 pencil equals 110 minus 50, which is 60. So pencil, divide both sides by 2, is 30. Okay, let's clean up this board. We've got some really useful information there. Pencil is 30. This can help us because we know that the pen right here is pencil plus 50. So if pencil is 30, then pen is simply 30 plus 50. So pen has to be 80p, which is D. So D is our answer. And that's definitely one of the harder, more advanced questions. But once you understand the concepts that underpin it, you can get it right every single time. Our answer is D. Okay, so here for this next question, we have some simple questions, but we have to make sure we make no silly mistakes. First, we have 454 plus 297. So let's work that out, remembering to show our working as the question asks us to. Plus 297. Well, we could use column addition and work it out this way. So 4 plus 7 gives us 11. So 1, carry the 10. Then 1 plus 5 plus 9, well, that's 6. Plus the 9 is 15. So 5, carry the 1 over. Then 1 plus 4 plus 2. So 5, 2, 7. 7, 5, 1. Right? Or we could use mental maths. And maybe we don't use mental maths to answer the question because they want to see working. But we can use mental maths to check our answer, to see if we made any silly mistakes. And how would we use mental maths here? Well, we would realize that 297 is very close to 300. It's only 3 off 300. So what we can do is we can simply, in our head, do 454 plus 300, which is 754. And then we minus the 3, giving us 751, which is indeed our answer. So understanding and building your mental maths is so useful for your 11 plus exam. When we can do this efficiently, it helps us to check our work and also helps us to get answers right in a fraction of the time of doing longer, more drawn out methods many times. So here we have 604 minus 447. Here, let's do the actual column subtraction. First, we have 4 minus 7. We can't do that. So we take a 10 from here. We can't do that. So we take a 10 from here instead. This goes from 6 to 5. This becomes 10, or 9 now. And this becomes 14. So now we have 14 minus 7, which we can do because 14 is bigger than 7. And this gives us 7. Then we have 9 minus 4, which is 5. Then we have 5 minus 4, which is 1. So 157. Okay, so now we have 32 times 74. So let's work this out. 32, 74, we have 2 times 4, which is 8. 3 times 4, which is 12, so 2 carry the 1. 7 times 2, which is 14. Add the 1 is 15. And then we have 3 times 7, which is 21. Add the 1 is 22. So now we have 8, 7, 2, 2, 2,278. And then here we have 4, 1, 8, 4 divided by 8. Well, 8 into 4 we can't do, so 8 into 40, we have 5, right? Because 5 times 8 is 40. And then we have a 1 left over. So now we bring down the next number, which is the 8, and we have 8 into 18. Well, that's going to be 2, right? Because 8 times 2 is 16. And we have 2 left over, bring down the 4. And then we have 8 into 24, which is 3. 8, 16, 24. Really helpful if we know our times tables just like that. So 3. So here we have no remainders. Our answer is 5, 2, 3. Okay, so now let's go through each of these parts, part A, B, C, D, one by one, and let's work these out. So first for part A, we have 5 ninths plus 2 ninths, 5 over 9 plus 2 over 9. Here they've made our life pretty easy because we already have a common denominator, right? We have the numerator up top, denominator at the bottom. Because both denominators are the same, we call this a common denominator. And therefore, all we have to do to work this out is add across the numerators. So 5 plus 2, 7 over 9. The denominator stays the same. So 7 over 9 is our answer. Pretty simple, pretty quick. Then we have part B, 3/4 plus 1 over 8. So here we don't have a common denominator. So we need to create a common denominator. And we're going to do this by multiplying both the numerator and denominator of this left fraction, do that a bit better, by 2. When we do this, what happens? Well, we have 6 on top, numerator. Then what do we have on the bottom? 8, which is really useful because now we have 6 over 8 plus 1 over 8, common denominator. We can add across the numerators, 7 over 8. Then we have 5 over 6 minus 1 over 2. Same concept. We're searching for the common denominator. Here we multiply by 3. So it's going to be 5 over 6 minus 3 over 6, giving us 2 over 6, or 1 over 3 when we simplify. And finally for D, we have 7 minus 3 over 7. Now here the trick is understanding that 7, yes, it's a whole number, but it's the exact same thing as 7 over 1. Any number is the same as that number over 1. We could have 1,000,000. And 1,000,000 is still the same thing as 1,000,000 over 1. So let's rub this out. If we have 7 over 1 minus 3 over 7, we do the same thing. Common denominator. Multiply this left fraction, top and bottom, numerator and denominator by 7, giving us 7 times 7 on the top, times tables, 49, over 7, minus 3 over 7. Subtract across the numerators, denominator stays the same. We have 46 over 7. And this is an improper fraction, where the numerator is greater than the denominator. But we can also turn this into a mixed number in case the question asks for it, or maybe you worked it out as a mixed number. How can we do this? Well, we simply take this division, 46 divided by 7, and we try and replicate it. So here, if we work this out, how many 7s go into 46? Well, if you know your times tables, you know 7 times 7 is 49, which means it has to be 6, because 7 times 6 is 42. And we have a remainder, therefore, of 46 minus 42 of 4, right? So let's break down what does this mean. It's telling us that 7 goes into 46 6 times, remainder 4. And therefore our mixed number is 6, because it goes into 46 6 whole times. And the fraction part of this mixed number will be 4 over 7. The remainder over the divisor. 6 and 4/7. Whole part, fraction part. So the answer is 46 over 7, improper fraction, or 6 and 4/7, mixed number. Both answers are correct. Okay, so here we have to try and work out what's going on and the patterns in these sequences. And when we work out this pattern, it will help us to work out the missing numbers, or the next 2 numbers in the sequence. So first one, 7, 10, 13, 16. Nice and easy, simple addition. We're adding 3 each time. So it should be 16 plus 3, 19, and then 19 plus 3, 22. Then we have 53, 49, 45, 41. Now we're subtracting, but again, it's the same number each time. Super easy. We like these kind of questions. Subtracting 4 from each number. So now we have 41 minus 4, giving us 37. Be careful when we're going backwards, not to make any silly mistakes. And then we have 37 minus 4, giving us 33. Now we have 6, 10, 15, 21. Well, let's look at the difference. Plus 4, plus 5, plus 6. Okay, we can see what's going on here. It's going to be plus 7 and then plus 8 to continue that pattern. So plus 7 is going to be 28, plus 8 is going to be 36. Awesome. Next one, we have 60, 58, 63, 61. What's going on here? At first, it seems a bit confusing because we're going down and then we're going up and then we're going down. I mean, it's 8 and then it's minus 5 and then it's 2. What's going on? The key here is to understand that the relationship is between every other number, not consecutive numbers next to each other. So here, the relationship is 60 to 63 because we're adding 3. And then we have 58 to 61. Again, we're adding 3. So now we can continue this pattern to find both our numbers. Plus 3, plus 3. So 63 plus 3 gives us 66. 61 plus 3 gives us 64. So those are our answers, 66 and 64. And it's from recognizing that the pattern is between every other number. So watch out for that sometimes when we see it in the exam. Now we have 0.5 to 832. So here, the numbers are getting very big very quickly, right? From 0.5, half of 1, all the way to 2, then 8, and 32. So there has to be some sort of multiplication going on here to make those numbers get very big very quickly. So here, if we look closely, we're multiplying by 4 each time. 0.5 times 4 gives us 2. 2 times 4 gives us 8. 8 times 4, 32. 32 times 4 is what? Well, let's use our mental maths. 32 times 4 is 30 times 4 plus 2 times 4, right? Because 32 is 30 and 2. 30 times 4 is 120. To make it simpler, 3 times 4, which is 12. So add a 0 because we're doing 30 times 4, so 120. Then we have 2 times 4, which is 8. So 120 plus the 8 gives us 128. And then we have 128 times 4. Here it might be quicker to do it using our normal method, our non-mental maths method. 8 times 4, 32. Carry the 3. 2 times 4, 8. Add the 3, 11. 1 times 4, 4. Add the 1, 5. 512. These are our answers. Okay, so now we have to put the following in order, starting with the smallest. And again, we're going to draw upon our knowledge from the decimals questions beforehand. Different columns, tenths, hundredths, thousands, so on and so forth. So here, starting with the smallest, well, we're going to start by assessing the tens column because all these numbers don't go past the tens column, not tenths, tens. So on the left-hand side of the decimal point. Here, we have no tens, 0 tens. Here we have 5 tens, 3 tens, 0 tens, 5 tens, 0 tens. Okay, so smallest is going to be one of these numbers with 0 tens. So now let's move to the units column. Here we have 3, then we have 5, then we have 5. Okay, so the smallest is going to be this one here with the 3 as a unit. We don't need to look any further to the right-hand side. So smallest, 3.55. Now let's look to these two ones that have 5 in the units column. We have 5.35 and 5.53. Well, in this tenths column, 3 is smaller than 5. 3/10 is smaller than 5/10. And therefore, this is the next smallest number, followed by this one. So now we've counted out these numbers. Let's move to these next ones. We have 53.5, 35.5, 55.3. Well, here, if we look at the tens column, we see the 3 is smaller than the 5 and the 5. So this has to be the next smallest number, 35.5. Then we have 53.5, 55.3, units column, 3 smaller than 5. So we don't need to look any further. It has to be 53.5 and then 55.3. This is our order from smallest to biggest. Okay, so for this next question, we have to draw lines of symmetry on these shapes. And we're told already that some may have no lines of symmetry and some may have more than one line of symmetry. So when we're thinking about lines of symmetry, don't get thrown off and think it's so complex. The main thing I want us to think about is drawing lines that cut through the shape, that if we were to fold that shape over that line, there would be no overlaps. When you think about lines of symmetry in this way, it makes it so much more simple. For each of these shapes, we're trying to draw a line where if we fold the shape on that line and we fold it over, there would be no overlaps. So here, for part A, we have 2 lines of symmetry. You can see I've already drawn one. Line's not perfect, but you can see here, this is our first line of symmetry, because if we were to fold this part over this line I've drawn, you can see there will be no overlaps. This section here would perfectly line up with this section here, and therefore it's a line of symmetry, right? It's almost like you're drawing a line where each side is a perfect reflection of the other. So the second line of symmetry would be over here, across this diagonal. Because again, if we were to fold this shape on that line I just drawn, there would be no overlaps. So for this question, you don't have to get it exactly right to the millimeter, but generally you want to show the examiner that we understand what's going on. And we understand there's one line of symmetry roughly here from top left to bottom right, and there's one roughly here from top right to bottom left. Now for B, this is more of a tricky one because there isn't really any line of symmetry. We have a very irregular looking shape, and therefore there are no real lines that we could fold this shape on where there would be no overlaps. Perhaps you could argue for this line here, but these 2 sections of the shape don't really seem equal enough for us to fold over one section and for there to be no overlaps. And therefore for B, I would say there are no lines of symmetry, no lines where we can fold the shape over those lines and there will be no overlaps. So let's leave B with nothing. C, we do have a line of symmetry, and it's going to be right here across this diagonal. We can see it passes our test. If we were to fold this bit over and collapse it over here, there'll be no overlap. This section here would perfectly align with this section here, and therefore we know it truly is a line of symmetry. And finally, for part D, we have this parallelogram. So for this shape, we actually have no lines of symmetry. There are no lines we can draw on the parallelogram where we can fold the shape over that line and there will be no overlaps. We can't do it across this diagonal because if we fold it over, it won't exactly line up. And same thing with this diagonal. So, same thing with directly vertical or horizontal. It just doesn't work. So we need to remember and understand that when it comes to parallelograms, we have zero lines of symmetry. So this will be our final answer. A, B, C, D. A and C have lines of symmetry. B and D are parallelogram, do not have any lines of symmetry. Okay, so here we have to reflect shape A in the x-axis. So let's do that. We have the x-axis right here. So let's take it point by point. We don't rush these reflection questions. We take it step by step. And doing that means we can come away with the correct answer. So here we're 1 away from the line of reflection. And therefore, we do the same thing on the other side. So here is our first point of our new shape. Same thing here. 1, 2, 3, line of reflection. Put it in red. In our new area, same thing. 1, 2, 3. Next point. Here, we are 1, 2 away from the line of reflection. So again, 1, 2. Here's our new point. And once we connect them, we have our new reflected shape. And we call this new shape B. Then for part B, we're going to reflect shape B in the y-axis and label this new shape C. So same thing, we have our y-axis here, right? X and Y. This is the Y. So step by step, same thing. 1 away from the line of reflection. So again, we're going to go 1 away, new point. Here we are 1, 2, 3 away. So we're going to go 1, 2, 3 away. Then here we are 1, 2, 3, 4 away. So we're going to go 1, 2, 3, 4. Here's our point. Connect these points. 2, 3, and this gives us our new reflected shape, which we label C. Here is our answer. Always take these questions step by step. Okay, so now let's go through question 17. Steve has counted the number of goals he scored in 6 five-a-side football games. And the counts were 3 goals, 4 goals, 2 goals, no goals, 1 goal, and 8 goals. Okay, so we have that data, that information there. First, we have to work out the mean score for the games he counted. So for the mean, how do we work this out? We take the total and we divide it by how many data points we have, how many values. Number of values. So here, what's the total? What's the numerator? Well, we have 3 plus 4 plus 2 plus 0 plus 1 plus 8. So mental maths. 7, 9, 10, 18. So total 18. How many games did he count? Well, we're told it's 6. So 18 over 6 should give us 3. So the mean score was 3 goals. And then what was the range? Well, for the range, it's always the largest minus the smallest. And that's going to be the 8 goals he scored minus the 0 goals he scored. So the range is 8 goals. And now for part C, we're adding a bit more complexity to the question. In the next game, he scored enough goals to increase his mean, which was 3, to 4. How many goals did he score in the 7th game? So to answer this question, we need to understand this formula we use to calculate the mean on a deeper level, right? Because we're given some more information. we're told the mean is now 4. So the total over the number of values, or in this case, number of games, is no longer 3, it's now 4. What else do we know? Well, we also know the number of games has increased, right? It's gone up because he's played an extra game in the next game. So now we have not 6 games, but 7 games. So let's just take it step by step and rewrite this formula. The mean is going to be total goals scored over number of values, number of games, which in this case is 7. And we're told this mean has increased to 4. So how many goals did he score in the 7th game? Well, if we rearrange this equation by multiplying both sides by 7, we work out that the total has to equal 4 times 7, which is 28. So before, our total was 18, remember, for the 6 games. But now we've played 7 games. Our total for this to work has to be what? 28. So we've gone from 18 to 28. So knowing that, how many goals must Steve have scored in the 7th game? It has to be 10. That's the only way to bump up, to increase our total enough to increase our mean to 4. And that's how we work it out. 10 goals is our answer. Okay, so here for this next question, part A, we're told on a train there are 140 men and 200 women. What is the ratio of men to women written in its simplest form? So men we can call M, women we can call W. We have 140 to 200. So first of all, we can take out the common factor of 10, which gives us 14 out of 20. Then we can take out the common factor of 2, just like in fractions. And doing that, well, 2 times 7 is 14, and 2 times 10 is 20. So the ratio in its simplest form would be 7 to 10 men to women. Now for part B, we're told that we're making a scale model of the Eiffel Tower, which in real life is meant to be 120 meters tall, okay? Very tall. But for our scale model that we're going to make, we're going to use the ratio 1 to 50. So therefore, how long will our scale model be in centimeters? So let's break this down. There are a few different parts to this question. First thing is understanding that we're going from meters here to centimeters. Okay, so let's be mindful of that. Now, the second thing we need to notice, which makes this question, is the ratio, right? We have 1 to 50. And that's telling us that in real life, so we have model to real life. So in real life, what would actually be 50 meters, we're going to only represent it as 1 meter in our model. And knowing this, we can put the 120 meters, which is the height of the actual real life Eiffel Tower. And we can work out how many meters the scale model must be. Well, let's think about it like this. When it comes to ratios, we can either scale it or keep it consistent in the vertical direction, or we can keep it consistent in the horizontal direction. We can use a different color here. So either vertically or horizontally. In this case, it may be easier to make it consistent horizontally. because we know we're trying to work out this value here. But we also know that going from 50 to 1, we divide by 50. And therefore, going from 120 to our mystery value, the scale height of the Eiffel Tower, we're also going to divide by 50. So really, to work it out, all we do is 120 divided by 50. And now we have familiar territory. Fractions. Take out the common factor of 10 or cancel the zeros. Then we have 12 over 5. We can work this out. 12 divided by 5. Well, 5 goes into 12 twice, giving us 10. And then we have 2. And then we can't put 5 into 2 wholly. So we add decimal point, add a 10 here. And 5 goes into 20 4 times. So it's 2.4 meters. That's the mystery value. But as we said at the start, how long will the model be in centimeters? This will be 240 centimeters because there are 100 centimeters in a single meter. So we times it by 100. So our answer is 240 centimeters. And now for part C, we're told my friend Sanjay is making a scale model of the London Ear. I haven't heard of that one before. A famous landmark in London. The London Ear is 80 meters tall and his model is 150 centimeters tall. What is the scale of the model in its simplest form? Okay, so here again we have the ratio and we're looking at model versus real life. So let's try and plug in some values. In real life, we know the London Ear is 80 meters tall and it's in meters, right? Be very careful about this. And in the model, we've modeled this by making it 150 centimeters tall, which is 1.5 meters tall. So now they're both in meters. And we know the ratio is 1.5 to 80. But let's turn that into its simplest form. We have 1.5 to 80. Let's get some more room. Let's first get it into whole numbers by multiplying both sides by 2. Now we have 3 to 160 model to real life. And since we can't go any further than that, that is the simplest form of this ratio, right? We can't divide 160 by 3 wholly into only a whole number. And therefore, the simplest form of this ratio is 3 to 160 model to real life. Okay, so now we're at question 19. So let's keep on going through this paper. Here, if we read the question, we're told that after some gardening, a cane went from 2.05 meters long to 156 centimeters long. And we need to work out what length of the cane was snapped off. And we do this by converting both to centimeters, because that allows us to compare these values a lot easier. So converting 2.05 meters to centimeters, we multiply by 100. So it's 205 centimeters. So now we have 205 minus 156, and we can work out what length was snapped off. Well, we have 5 minus 6, which we can't do, so we take a 10 from 2 to take a 10 from the 10, giving us 15 minus 6, which is 9. Then we have 9 minus 5, 4, 1 minus 1 is 0. So 49 centimeters is our answer. And now for part B, we're told that in her garden, she's sowing some grass seed. and the whole garden has an area of 158 meters squared, each packet is only enough to cover 12 meters squared. So we need to work out how many packets that she needs to buy. So here it's simple division. We have 158 divided by 12. Well, 12 goes into 15 how many times? Once. Remainder 3. And 12 goes into 38 how many times? It's going to be 3 times, because 12 times 3 is 36. But the problem here is that this leaves a remainder of 2. And if we're trying to cover the whole garden, we can't have any remainders. We have to buy more than enough. And therefore, she won't buy 13 packets. She'll buy 1 more to make sure there's no remainder, which means she'll buy 14 packets. So now for question 20, we have a nice little scenario about Farmer Giles and his cows and counting the total number of legs. We're already told that if there's only 1 cow, there will be 6 legs in total, 4 from the cow and 2 from Farmer Giles. But how does that increase when we have 2 cows, 4 cows, 10 cows, 100 cows? Let's fill in this table. So 2 cows, well, it's going to be 2 times the 4 legs, which is 8. Add the 2, which is 10. What about 4 cows? Well, it's going to be not 2 now, but 4 times the 4 legs, which is 16. Add the same 2, which is 18. What about 10 cows? Well, it's going to be 10 times the 4 legs, which is 40. Add the 2, which is 42. What about 100 cows? And notice which numbers we have to erase and which numbers we can leave in place. For number of cows, it's going to be 100 cows times the 4, 400. Add the 2, 402. So now we've filled this table, we're trying to write a formula that links the number of cows, C, to the number of legs, L. Fill in the gaps to help her. So L equals something times C, number of cows, plus something. What numbers did we leave alone when we were working out the total number of legs as the number of cows changed? No matter what, we will always multiplying by 4, because a cow has 4 legs, and then we will always adding on 2 for Farmer Giles, who has 2 legs. So even if it was 1,000 cows, it would be 1,000 times 4, or 1,000 times the number of legs which the cows have, which is 4, added on to 2 for Farmer Giles. So here it's going to be L, or legs, equals 4 times the number of cows plus 2 to accommodate for Farmer Giles. And let's check it. Let's just make sure that we're correct by using some of these values in the table. Let's take this one here. So here, writing this out, we have L equals 14, number of legs in total. And this should equal 4 times C, number of cows, which is 3, add 2. And indeed, 14 equals 4 times 3, which is 12, plus 2. So our formula is correct. L equals 4C, 4 times the number of cows, plus 2. Okay, for this next question, again, we have a few steps. So let's take it methodically, step by step. On my wall, I want to put some stickers of my favorite pop star, Singing Steve. Okay. the space I have available is 55 centimeters by 60 centimeters. So let's visualize this. This is the total space we have available. And each of these stickers of the favorite pop star, Singing Steve, are 15 centimeters by 5 centimeters. So we have smaller stickers that we're trying to put onto the wall. How many of these stickers can we fit? So we need to work out the area of each of these two bits and bobs. So the area of the wall, and then the area of the stickers. And then we can simply divide the area of the wall by the area of the stickers to work out how many of these stickers can fit onto the wall. So let's start with the area of the wall. We have 55 times 60. Well, let's use our mental maths. 55 times 60 is simply going to be 55 times 6 multiplied by 10, or just add a 0. So 55 times 6 is what? Well, 50 times 6 is 300, because 5 times 6 is 30. So 50 times 6 is 300. And then 5 times 6 is 30. So we have the 300 plus the 30, 330. But now, since it's not 55 times 6, but 55 times 60, it's not 330, it's going to be 3,300. So that's the area of the wall using mental maths. I told you it was quicker. And then we have the area of the stickers. Here we have 15 times 5. Well, 15 times 5, 10 times 5, because notice 15 again is 10 and 5. So 10 times 5 is 50, 5 times 5 is 25. 50 plus 25 is 75. So we have 3,300 divided by 75. Okay, so how are we going to work this out? Here, we could use long division, or we could do something a bit more stealthy that could save us some time. Maybe we're running out of time and we need to work this out very quickly. 3,300 divided by 75. Watch this. This could be a scholarship level question. So we have 3,300 divided by 75. Okay. And instead of wasting time going the long way around and doing long division, we could simply recognize that 75 is half of 150, right? 75 times 2 is 150, and times that by 2 again is 300. So effectively, 75 times 4 is 300. Now, how many 300s go into 3,300? That's a bit more simple to do using our mental maths, right? Because 300 times 10 is going to be 3,000. But then to get to the extra 3,300, we need one more lot of 300. So overall, it's going to be 300 times 11. 300 times 11 gives us 3,300. But if 300 times 11 gives us 3,300, and 75 times 4 is 300, or 300 is just 4 times more than 75, that means if we're looking at 75s into 3,300 and not 300s into 3,300, it's going to be 4 times more. So instead of it being times 11, it's going to be times 11 times 4. Or in other words, it's going to be times 44. So 75 goes into 3,300 44 times. And that is a way to use mental maths to answer high-level questions efficiently and quickly. The answer is the maximum number is 44 stickers. And that can be the difference between getting the answer correct and finishing the paper versus running out of time. The mental maths. Okay, so here for this next question, we're told there are two runners having a race. Gary starts running from the start line at 10 meters per second. 2 seconds later, Andy starts running from the start line at 12 meters per second. Part A, we have to work out how long after Gary starts running does Andy catch up with him. So how do we think about this kind of question? The first thing is really understanding what's going on and understanding what the examiner means when they say 10 meters per second. This literally means that every single second, right? So when we have 10 meters per second, instead of just seeing it as a metric, understand what's truly going on. If someone's traveling at 10 meters per second, every single second time, they're traveling a distance of 10 meters. So we have the distance traveled for every single unit of time. So visually, we can think about this. Usually it helps when you try and think about things visually. So on one side, we have Gary. Let's call Gary G. And he starts at the start line. He's running 10 meters per second. That means every single second, we have second 1, second 2, second 3, so on and so forth. Every single second, he's traveled 10 meters. Then again, 10 meters. Every single second, he's traveled an extra 10 meters. And then 2 seconds later, we're told Andy starts running from the line at 12 meters per second. So for Andy, every single second, we'll put it in red, every single second, Andy's running 12 meters. Another 12 meters. So how do we use this information to work this question out? Well, think about it like this. We're told that Andy starts running 2 seconds after Gary has started. So knowing what we know about Gary's meter coverage every single second, how many meters would Gary have already run in those 2 seconds where Andy hadn't started yet? Well, if Gary's running at 10 meters per second, then in those 2 seconds where Andy hasn't started yet, Gary is ahead by how many meters? He's ahead by 20 meters. That's how much Gary's ahead by, 20 meters. What's the second thing we know? We know that compared to Gary, Andy is running 2 meters more every single second. So every second we said, remember, Gary's running 10 meters. In that same second, Andy's running 12 meters. So every second he's running 2 meters more. So effectively, we can work out this question by thinking about how long it will take Andy to make up that 20 meter gap. And of course, if he's running 2 extra meters every second, it will take him 10 seconds to make up that 20 meter gap. 10 seconds times 2 meters gives us that 20 meters. So that's the answer to part A. The answer is 10 seconds. 10 seconds after Gary starts. Okay. So that's our answer. How long after Gary starts running does Andy catch up with him? 10 seconds after. Because remember, he's running those 2 extra meters every second. 10 meters per second versus 12 meters per second. Okay, so now for part B, this should be pretty simple if we understood everything that was going on in part A. We have to work out how far they both are from the start line when Andy catches up with Gary. Now we know that once Andy starts moving, 10 seconds it takes before he catches up with Gary. We worked that out in part A. So now all we have to do is knowing how long Andy's traveling for at the time, and also knowing his speed, which is 12 meters per second, we can work out the distance that Andy covered before he caught up with Gary. And this will be the place where they both meet. That's our answer. So to work this out, we need to understand the speed, distance, time triangle. And this helps us to work out all the questions regarding speed, distance, time. Questions like this. So this is how it works. We have speed, distance, and time in this triangle. And pretty much we can work out how to find each of these elements by covering up another one of those elements. So for example, if we want to work out speed, we simply cover up speed in our speed, distance, time triangle. And this triangle tells us that to work out speed, we take distance and we divide it by time. Same thing if we want to work out time, cover up time, it's distance divided by speed. And then if you want to work out distance, this time it's a bit different. It's going to be speed times time. So that's the speed, distance, time triangle. Super useful for our 11 plus exams. So now back to this question, how far are they both from the start line? So the word far lets us know we're looking at distance. So here we want the speed and we want to multiply that by the time. So the time Andy takes to catch up is 10 seconds. The speed is 12 meters per second, and therefore the distance is going to be 120 meters. That is our answer. So here for this question, we simply have to work out the difference between these two numbers and then use that to work out what A and then B should be. So not too complicated. For part A, we have 0.2 and 1.2, difference being 1, and therefore halfway should be 0.5. So this should be 0.7, and that makes sense because we go from 0.2 plus 0.5 plus 0.5. So 0.7. And same concept here, 0.7 to 1.8 is 1.1. Half of 1.1 is going to be 0.55. And therefore, we do 0.7 plus 0.55, giving us 5, 2, carry the 1, the decimal point, 1.25. So these are our answers. Okay, so to start off with this question, we're simply marking some coordinates onto the graph. So it shouldn't be too hard. Part A, mark the point with coordinates 0, 4. So we remember coordinates, it always describes how far to the right we go and then how far up. Right and then up. And then when it's negative, it's the opposite. So left and then down. So for B, 0, 4, we're not going to the left or right, or going 1, 2, 3, 4 up. Then for part B, -3, 0, we're going 1, 2, 3 to the left, 0 down. So it's going to be right here. And then the point D forms a square A, B, C, D. Write down the coordinates of point D. So here we need to know the attributes of a square that make it a square. The main thing is that in a square, every side is of equal length. So therefore, we have to find a point, a coordinate, that when we join it up to the other coordinates, every side is of equal length. So let's work out first the length of each side. So let's join up what we have already. We have something like this. Okay. So first and foremost, how are we going to work out the length of the side? Well, we can simply use this understanding right here. If we want to go from A to B, we go 1, 2, 3, 4 across, 1, 2, 3 up. Same thing going from B to C. We go 1, 2, 3 across, 1, 2, 3, 4 down, right? So it's 3, 4, 3, 4. We can use that to try and find out roughly where this next point should be, because it should be 1, 2, 3, 4 across, 1, 2, 3 down. It should be right here. And let's confirm, if we join up these sides, we see we have what looks like a square. And if we did it differently, let's say 1, 2, 3 across, then 1, 2, 3, 4 down, that would have given us a point here, which when we join it up, does not look like a square. And therefore, we can be pretty confident that this point that we drew out, 1, 2, 3, 4 across, 1, 2, 3 down, is indeed the final coordinate that completes the square. And here we're looking at 1 minus 3. 1 to the right, 3 down. So the coordinates of point D are going to be 1 minus 3. Now for part D, we have to work out the area of this square we have just created. And as always, when we're working out the area of larger shapes, the best thing to do when it's not immediately obvious is to turn it into more familiar shapes. So here, the best way to approach it is to split this square up into different shapes, because it's a bit awkward. So if we do this, we now have some familiar shapes. We have one triangle here, another one here, another one here, another one here, and then a rectangle in the middle. So first, let's tackle triangle 1. We know the area of a triangle is base times height divided by 2, or width times height divided by 2, right? So here, our base is what? We're going from 4 to minus 2. So our base is going to be 6. Our height is 1, 2, 3. So we have 6 times 3 over 2, or 9. So let's put 9 over here. 9. So we have 1, 2, 3, 4, 5. 1 is 9. Then we have 2. Well, for 2, what's our base? Well, now we're going from this coordinate, so 3, all the way down to this coordinate, so minus 3. So again, it's going to be 6 times 1, 2, 3, the height, over 2. So same thing, 9. Okay. What about 3? Well, 3, we have a smaller triangle over here. In this case, the base is 1, the height is 1. So therefore, we have 1 times 1 over 2, which is a half. So we have 0.5 and 0.5. And finally, we have our rectangle in the middle. Here we have the formula is simply length times width, width times length, length times width, same thing. So what is our length? We have 1, 2, 3, 4, 5 times the width of 1, which we can see pretty clearly. And this gives us 5. So slowly but surely we're getting through this question. Now we simply add up these different areas and it should give us the total area. 9 plus 9 is 18, plus 0.5 and 0.5 is 19, because these two add up to give us 1. So 18, 19, 19 plus 5, 24. So the area of the square is 24 centimeters squared, if we assume that this is a centimeter grid. Okay, so that is our answer. Now here for this next question, we're shown some information on two cars racing from Leeds to Blackpool and back again based on this line graph. So part A, how far is it from Leeds to Blackpool? Well, here we have on the x-axis time and on the y-axis distance. So if they're going from Leeds to Blackpool and then from Blackpool back to Leeds, then this turning point should represent when they've reached Blackpool. And therefore, if they reach Blackpool after 120 kilometers that they've traveled from Leeds, then it makes sense that Leeds is 120 kilometers away from Blackpool. So our answer should be 120 kilometers. Now for part B, which car was winning at 3:30? So time 3:30 is around here. If we trace upwards, we see car B has covered more distance because the y-axis shows us distance than car A. And that's because for this time, 3:30, the line for car B is higher than the line for car A. So car B's covered more distance, and if you've covered more distance, that means you're winning. So therefore car B is winning. Now for part C, we have to apply some logic and reasoning to answer this correctly, because we're asked again which car was winning, but this time at 4:15, which is around here. If we trace up, we see that although car A, the bold line, is higher than car B, the dotted line, car B has already reached Blackpool and they're on their way back to Leeds. Whereas car A is still trying to get to Blackpool. So even though the line is higher, they're still losing because car B is on their way back to Leeds. And therefore at 4:15, car B is still winning. Now for part D, we need to work out the distance between the cars at 4:45. So here's pretty simple. We can use a different color to make it clearer. The one car has traveled 60, or is that 60 kilometers from Leeds? And the other car is 100 kilometers from Leeds, distance from Leeds. And all we care about really is the difference. And that difference is 40 kilometers, which means that at 4:45, the distance between them is 40 kilometers. Now, part E, what happened just after 6 p.m.? Well, around this area, just after 6 p.m., we see the lines cross. And what does that mean? Well, if the lines are crossing on the way back from Blackpool, that means that someone is overtaking the other person. And as we can see here, the dotted line, car B, is overtaking the solid bold line, car A. And actually they end up getting back to Leeds before car A. So to answer the question, just after 6 p.m., car B overtakes car A. And we can see this through the lines crossing. They're at the same distance at that point in time. For part F, we have which car achieved the highest speed and between which times did this happen. So to answer this, let's clear this graph a bit. Which car achieved the highest speed and at what time, or between which times, did this happen? So to work this out, we need to understand the relationship between speed, distance, and time. And that's that speed equals distance over time. And we know this through our speed, distance, time triangle, right? Very important triangle for the 11 plus. Whatever we cover gives us information about the other two. So if we cover speed, we want to find out about speed, we cover it up. And we see speed is distance over time. Time, cover it up. Time is distance over speed. Want to find out about distance, cover it up. Distance is speed times time. So here, speed is distance over time, as we see right here. So we're trying to work out, to find the highest speed, we want the highest distance traveled in the shortest amount of time. And the way we're going to see that on the graph is by a very steep line. For example, this line over here, we can see, if we take a look at this line, we've covered a lot of distance on the y-axis in a short amount of time on the x-axis. So we're going pretty quickly there. But if we compare that to this area over here, we've covered zero distance. Over here, we're at 60 kilometers from Leeds. Here, we're still at 60 kilometers from Leeds, but time has passed. And therefore, it's a very low distance and a high time. And therefore, it's a low speed. So here, we're looking for steep lines. So here, this line could be a contender. And also this line could be a contender. So let's work out the speeds for these three lines. Those look like the steepest lines in the graph. So the first one we have here. What's the distance? What's the time? Distance, we're going from 50 to 120. So scenario one, distance is 70 kilometers. Time, well, trace it down. We're going from 3:15 to 3:45. So 30 minutes. So 70 kilometers in 0.5 hours. What about scenario two over here? How many kilometers in distance? We're going from 120 to 40. So 80 kilometers. What's the time? Well, trace it downwards. We're going from 4:30 to 5:30. So 80 kilometers in 1 hour. And what about scenario three? Let's clear up our page. Scenario three, we said, is over here, the next steepest line. Distance here is 60 to 0, so 60 kilometers. And the time, trace it down, 5:45 to 6:15, so 30 minutes or 0.5 hours. So what's going to be the highest speed? Well, straight away, we know that 1 has to be quicker than 3, because for the same time on the denominator, we're traveling more distance. Think about our speed, distance, time relationship. More distance in the same amount of time means you're running quicker. So 1 cancels out 3, but then we have 80 and 1 hour. So scenario 2. Well, let's think about it. If we're running at a speed of 70 kilometers in 0.5 hours, that means in 1 hour, we would have run 140 kilometers, which is way more than running 80 kilometers in 1 hour. So by making this comparison, it's clear that we must be going way faster in scenario 1 than in scenario 2. Because if we continue at the rate of scenario 1, we cover way more distance in the same time. and therefore scenario 1 seems to be the quickest. So let's clear all this up. We have our answer. Scenario 1, the first one we did over here, is where we're achieving the highest speed. So it's going to be car B achieving the highest speed, and between the times 3:15 p.m. and 3:45 p.m. That is our answer. Now, finally, to end it off, which car won this race? We already looked at this. The car that won the race is the car that gets back to 0 kilometers in the quickest time. And that means it's going to be car B right here. So car B is the winner. Okay, so here for this next question, we have to try out some different numbers. And eventually, we want to find some numbers that will replace A, B, and C correctly in this sum. So it might not pop out immediately, but let's see if we can understand how this works. So for example, let's say C was equal to 1. That would mean that 1, 1, 1 equals 3. So B would equal 3. But then if B equals 3, we have 3 plus 3 plus 3, which is 9, which doesn't work because B is meant to be 3. So we can see how we're going to have to try out a few numbers for this to work. And let's say C was 4. We'd have 4 plus 4 plus 4, which would be 4, 8, 12. So 2, carry the 1. Now if B is 2, that's 2, 2, 2, which is 2, 4, 6, plus the 1 is 7. But then again, that does not work because B is meant to be 2 and not 7. But if we look closely at this sum, we can kind of expect C to be a number that when we add up these 3 C's gives us a remainder, gives us a tens number that we can then add on to this column to make this whole thing work. So for example, if we try 8 and C equals 8, then what do we get? We have 8 plus 8 plus 8, which is 8, 16, 24. So 4, carry the 2. And then we have 4 plus 4 plus 4, which is 4, 8, 12. Add the 2 is 14, which works. And then we have A plus A plus A equals B. Now, if B is 4, A would have to equal 1. We have 1 plus 1 plus 1, which is 3. Add the 1 we carried over, which gives us 4. So it's a bit of trial and error. But here we can work out that A has to equal 1, B equals 4, and C equals 8. So 1, 4, 8. Here's our answer. Okay, now here for this final question, part B, we have a challenging question. And we're going to have to tackle this step by step once again, using all the logic and reasoning that we can find within our brains. So for this question, we're asked to find a 4-digit number which is reversed when multiplied by 9. So here we're showing the example of what has to happen. So if the number is A, B, C, D, when we multiply that number by 9, the result should be D, C, B, A. So let's first of all just put A, B, C, D here on the left, okay? These are the values we're going to have to work out, these letters. And let's start by just applying some reasoning and logic. Like I said, this is definitely a scholarship level question or an advanced level question for the grammar school tests, but we can still work it out if we use our logic and we don't give up. So first things first, we have a 4-digit number And when we multiply it by 9, the result has to be another 4-digit number. What does that tell us about what A has to be? A has to be 1. It cannot be 2. And the reason A cannot be 2, 3, or any number greater than 1 is because if A is greater than 1, let's say it's 2, for example, which would be 2,000, right? Because we have A 1,000, B 100, C tens, D units. If A is bigger than 1 and we have 2,000s, when we multiply that by 9, we get 18,000, which is a 5-digit number, no longer a 4-digit number, right? And same thing for any number 2 or above. And of course, it can't be 0 because that would no longer be a 4-digit number. So using our logic and the constraints of the question, A has to be 1. That's useful. Now, if A has to be 1, what does that mean? That means that when we multiply this thing by 9, the last number is also going to be 1, right? Because A equals 1. But if that last number is going to be 1, what does that tell us about the last number of A, B, C, D? It has to be 9. And the reason we know that, again, is because we're multiplying by 9. So that means whatever our last number is, when we multiply it by 9, it has to leave a 1 at the end. So for example, if D was 2, then multiplying it by 9 gives us 18 with an 8 at the end. If D was 3, multiplying it by 9 gives us 27 with 7 at the end. So you can go on like this for every single number, and you realize that the only number that gives us a 1 when multiplying it by 9 is going to be that 9. So therefore, the last number, D, has to be 9. But then, if D is 9 over here, D has to also be 9 over here, which again makes sense. So now we have two numbers, A and D. A is 1, D is 9. Okay. Now, how do we work out B and C? Let's see if we can get through this last part of the question. Well, what's going on here? First, we have to realize that if D is indeed 9, then remember, this is 9 units. 9 units. And 9 units multiplied by 9, yes, is going to end in 1. But what's 9 times 9? It's not just 1, it's 81, right? 9 times 9 is 81. And that means that it's not just the 1 unit that we get when we do 9 times 9, but it's the 80 over here as well, or the 8 tens. And that's very important to understand. We don't just have the 1 unit, we have the 8 tens, or 80. And the reason that's important is because if we simply put this 8 here and we say, okay, that's going to be an 8, that would mean that B is 8, which means there has to be an 8 here as well, which wouldn't work, because if B is 8, that means we're doing 8 hundreds times 9, which is 7,200. And adding that 7,200 to our existing 9,000 will take us way over the 4-figure limit, DCBA. So we have a slight problem. And what we have to work out is we need a situation where we have a 0 here. Because only when we have a 0 here and we have a 0 here can we stick to this 4-figure limit. And again, the reason we know that is because let's say we had a 1 here. Yes, this would work in the sense that we have 100 times 9, which is 900. So we're adding 900 onto this thing. But that would be 981, which wouldn't work because we see that this is meant to be 1 and not 8. And of course, this can't be 2, because if it was 2 and we have 200 times 9, that's 1,800, which takes us over the 4-digit limit. So if you're staying with me, we know through process of elimination and also logic and reasoning that this can't be 1. It can't be anything above 1. It has to be 0. There has to be a 0 here. So here comes the crux of this last step. For this to be a 0, and we know we have 8 tens to add to this column right here, we have to think about what this number here is going to be. Because here is still our tens column. So whatever C is, when we multiply this by 9, it has to give us a number such that when we add it onto 80, our 8 tens, it gives us something 0, 1. And the only way that will work is if we add 20 to 80, or we add 120 to 80, or we had 220 to 80. It's only these numbers that when we add them to 80, will give us numbers that have the 0 we need right here, because we know this has to be 0. So now we're thinking 20, 120, 220, 320. What number must C be to give us a value that is something 20? Because if C is 2, for example, 20 times 9 is 180. 30 times 9 is 270. But we want the 20 at the end, right? Because only the 20 we can add to 80 to give us a 0 here. Now, if you're good with your times tables, you will know what number multiplied by 9 will give us a value ending in 20. It has to be 80. Only 80 times 9 will give us 720. And when we add 80 to that 720, we get 800. And that allows us to have 800 here, and then the 1 from 9 times 9. So we had 9 times 9 giving us 81. And then we had the 80 times 9 giving us 720. So 720, add the 80, add the 1, overall gives us this 801, which we're seeing here, 801. Now, I hope you're still with me. I know this is not a very easy question. This is certainly going to be a scholarship level, high level 11 plus maths question. But if you get correct, you're going to get the best results in your 11 plus maths exam. But if you're still with me, first of all, well done. But second of all, this shows us that it's going to be an 8 here from the 801. But again, if it's an 8 here, that means C is 8, and it's an 8 here as well. And just like that, we have the numbers reversed. We have 1, 0, 899801. So B, back to red, B is 0 and C is 8. So A is 1, B is 0, C is 8, D is 9. If you got this question correct, put it down in the comments. I want to congratulate you because this is definitely a challenging question, but that's how we work it out. Okay, so that is all for today. Make sure you like the video, subscribe, and turn on notifications so that you're the first to know when the next video is released. And on that note, I will see you all next time.